Hi class. For this video we're going to look into the properties of parallel and perpendicular lines. And well, I guess a good way to describe parallel and perpendicular lines is specifically parallel lines have same slope. In other words, I could have one equation that say y equals 3x plus 2, and another equation could be y equals 3x plus 7. And if I was to graph these two, so I know one of them is going to be a y-intercept at 7, 1, 2, 3, 4, 5, 6, 7, and then a slope of 3, so I'm going to have a line that goes like this. I could also graph the other one at y-intercept of 2, and then I'm going to get a straight line with a slope of 3 right there. So what I'm looking for is specifically that same slope. Okay, so what does it take to have a perpendicular line? Well, the slope is actually the negative reciprocal. It probably is misspelled reciprocal, but you guys get the picture. So what that means is if my slope is, let's say, y equals 3x plus 2, if my slope is 3, I'm going to find the reciprocal of that. And so that 3, if I write that as a fraction, is going to be 3 over 1. And so the reciprocal of 3 over 1 is 1 over 3. And then what else is also important is I have to make it negative. So there's the negative sign. All said, if I start off with this line and I want a perpendicular point, or line, not point, if I want a perpendicular line, that new equation will be y equals negative 1/3. And then it could be plus 2 or plus 5 or plus 18. It doesn't matter. Let's just say it's plus 1. And what that'll give us is it'll give us a line that comes in and hits a second line and then forms a perfectly 90-degree angle. Okay, let's take a look at an example and figure out what some of this stuff means. Okay, so working with writing equations of parallel and perpendicular lines. Oftentimes the easiest way to do this is to work with point-slope form, and that's the y minus y1 equals m times x minus x1. And then we'll change it over to ultimately arrive to slope-intercept form, which is y equals mx plus b. Okay, so what I'm going to do is I'm going to look at this first problem, A, and look, I need to make a line that is parallel to y equals 1.5x plus 6 and goes through the line, or through the point 4, 5. The reason I use point-slope form is that I have a slope, and remember, if I have a line that's parallel to another line, the slope is the same, and I have a point. So that's easy. What I'm going to do is I'm going to say y minus y1, and that y1 is going to be this value right here, y minus 5, equals, and then 1.5 times x minus, and then x1, which is equal to 4. All right, there's our equation right there, and we know our point is going to be at 4, 5, and we know that our slope is going to be 1.5, but we need slope-intercept form. So from here, let's do a little bit of manipulation. I know I'm going to have to distribute my 1.5 in, so I'm going to have y minus 5 equals 1.5x minus, then 1.5 times 4 is going to be negative 6. We need to get y all alone, so I'm going to add 5 plus 5, and that leaves me with y equals 1.5x minus 1. Voila! All right, now, next up, let's do a perpendicular to the line y equals negative 3/4 x plus 2 going through this point. Okay. Well, I'm still going to use my point-slope form of y minus y1 equals m times x minus x1. All right. Now I know that my slope here in this case is negative 3/4. So slope equals negative 3/4. And because it's perpendicular, I need the negative inverse. In other words, I need to make this thing the opposite of what it is, so positive. Then I'm going to flip it around. So I get positive 4/3. This is my perpendicular slope. And then we're just going to do the same steps that we did earlier. So I'm going to say y minus negative 4, because I have a negative 4 value right here, equals 4/3 times x minus, and then x1 is going to be 6. All right, this simplifies to be y plus 4, and then I'm going to distribute, so let's get a different color here, into the parentheses here. So I'm going to have y plus 4 equals 4/3 x minus 4/3 times negative 6. Well, 4 times 6 is 24/3, and so this just turns into an 8. All right, and then to get y alone, we're going to subtract 4, and I'm left over with y equals 4/3 x minus, okay, so minus 8 and minus 4, minus 12. And this equation right here is the line that is perpendicular to our starting equation.